5 of June 2013. 12 June 2012. Question 5 is a big one. Look how big it is. I can't actually fit it on the screen. It's radians. Yeah, it's gonna be a killer. The first few are pretty easy, but again, it takes a bit of thinking for the rest. It's at this point, once you know you're in radians, hence that word there, you want to swap your calculators into radians. So if you remember right, you want to do shift menu, scroll down to your angles and select radians or rads or rad. Okay, these are the two equations you need to know. Literally, you need to know them off by heart. Yeah, let's just jump straight into it. So the very first question is find arc length PQ, so this one right here, and keep it as a multiple of pi. So you're literally going to do 18 times, r is the radius, so 18 there, times radians, it's the angle there, which is 2 pi over 3. You're going to do 18 times 2 divided by 3, you get 12. So the answer is 12 pi. And there it is, 2 marks. Really easy 2 marks actually. Moving on, the tangents of the circle PQ meet at point T. There's T. The angles TPO and TQO are both right angles. So these are 90 degrees here and that's 90 degrees there. The angle TPQ is alpha radians. Find alpha in terms of pi. So at this point it's 1 marker and it's actually quite an easy mark to get. All you need to know is what 90 degrees is in pi. So if you remember right, ooh, what the hell happened there? So if you remember right, you need to know 2 things. 2 pi is 360, pi is 180. If you know those 2 values, or at least just that one right there, you can extrapolate that and find out what 90 is. So 90 is going to be half pi. So you got half a pi here, and you got another half pi here. Oh, what's happening here? The next thing you need to know is how many degrees are there in one object, or the interior angles of an object. And if you remember right, it has to be 360. So these 4 angles have to add up to 2 pi, essentially. So that's all you need to know. You need to be able to convert from degrees and the knowledge you have in degrees to radians, essentially. So these 2 right angles together will give me 1 pi, because 2 half pi's just give me 1 full pi. I'm going to add on 2 pi over 3, and that equals 2. I'm actually going crazy here. I can't do that in my head. That bloody hell. 3 over 3, there we are. So that's me 5 over 3 pi. What I want though is alpha to make it into 2 pi, because that's the relationship I want there. So all I need to do to make this bit into 2 pi is basically I need a third pi. So if I add a third to this, it will give me basically 6 over 3 or 2 over pi. So alpha has to be 1/3 pi, and we're going to stick with that. So we'll stop there. There we are. Next thing we need to do is where is it? Where is it? Find the area of the shaded region bound by the arc PQ and the tangents TP and TQ. Give your answers to 3 significant figures. Now, so at this point, I need to point out something. 6 marks. 6 marks. First thing I would do is part 2, but the first thing I will do is work out what I can work out. And the easiest thing to work out by far is just the area of that sector there. So it's going to be this thing here. So it's going to be half of 18, which is 9. Oh, bollocks. It's going to be half of 18 squared. 18 squared divided by 2, it's going to be 162 times basically 2 pi over 3. Now, it does, I'm going to literally work it out. So that 162 times 2 pi over 3, that gives me an area of 339.29, blah blah blah. I'm going to round it up to 339.3. Now that will ensure me a couple of marks at least. I wouldn't be surprised if I got 1 mark here and 1 mark here. So I need to find either 2 marks somewhere. The other 2 marks are for this ridiculous part here. Let me get it right. So I've added a line in there to show you that there are 2 triangles there, or 2 right-angled triangles. And in fact, I'm just going to draw out the 2 right-angled triangles now. So I've got this situation here. I've got the 90 degrees here, and I don't have this as well. What I do have though is this angle here, which is half of this. So half of that is just going to be pi over 3. And I also have this angle here, which is half of alpha. And alpha is pi over 3, so this is half of that, pi over 6. Just for the sake of arguments, I'm going to use pi over 2 here as well. So in this comfy situation where we can essentially use the sine rule to find x and y, or the lengths x and y. So I'll do that quickly. So in fact, I need that, so I'm going to move it to the bottom. There we are. So I'm going to find x first, because x is alphabetically first. So x over sine pi over 3 is equal to, now I know this one, so I'm going to use that one, 18. I'll move this a bit as well so it looks a bit neater. 18 over sine pi over 6. So x is just this times by this. So let me just quickly work it out. So make sure your calculator is in radians, because if it's not in radians, you're pretty much screwed. So 18 divided by sine pi divided by 6. It's also, you want to make sure you get what's it called, your brackets in. So do this for your sines, okay? So make sure you, when you're doing sine, put your brackets in. So this box here is 36. I need to times it by this now. So if I times by sine, and again open brackets, pi divided by 3, I've got this massive length. It's not really massive, but a length of 31.1769, blah 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 blah. Again, it's up to me if I want to round it up. I will round it up. I'll do 3 significant figures. There we are. Again, I just need to find y now. So y is going to be y over sine pi half, or half pi, sorry, is equal to 18 over sine pi over 6. So if I do that, I actually don't need to find y, because it's just base times height divided by 2, but I'll find y for the sake of it. Let's do it quickly. So 18 divided by sine, that's pi over 6, and we'll times by sine pi over 2. So y should be 36, and again I don't need y, but I just found it anyway. So yeah, area of this triangle is just going to be base times height, so it's going to be 18 times 31.2 divided by 2. So if I do that, 18 times 31.2 divided by 2, it gives me 28.8, or 280.8. That's area of one triangle. I need to double it to find the area of this geometric shape called a kite. So if I times by 2, the kite is equal to this wonderful number, 561.6. So all I need to do now is to find this shaded region here, which is your kite minus your sector. We got the sector earlier, where is it? There it is. So if I do 561.6 minus 339.3, that should be my answer. So what was that? 339.3 to 222.3. And again, that was a lot of work. It is a 6 marker, and it threw basically a triangle question in there for you. So you need to be able to adapt to that. You need to be able to realize that's a right angle triangle. I can work that out. Work out the area of a triangle, double it for the kite, and just get on with it, really. I'm going to mark it because it's always nice to know how wrong I am. 12 pi. So you get 1 method mark for substitution, 1 mark for 12 pi. So let's get straight to that. So, where is it? There we are. So there's my substitution of that equation here. So 1 method mark there. And the answer, 12 pi. There we are. Move on to the next one. It is, where is it? Find alpha in terms of pi. So alpha is pi over 3. Pi over 3, you only get 1 mark. I think it's an A mark, or it might be a B mark. But this next question, this is really important. So area sector, that's the first thing you should go for. Substitution of the values, you get 1 mark. So substitution of these values here, 1 mark. So I can confirm that now, that is a method mark. Getting the answer, which is 108 pi, or 339 point, I'm round up 3, I will give you 1 mark. So I can confirm that is an actual mark as well. So is that an A mark? Yep, so that is an A mark. So you need to have this value here, or equivalent. You can't have error carried forward for this bit. It needs to be that 339.3 or 108 pi. From that point onwards, I presume the rest is for finding the triangle. So let's see here. They've done tan this is equal to that. Alright, it's weird. Let's just look for this. 36. So there's my y, there's my 36. I could get a mark there. I don't really want that 36 though. I want the other length. Where is it? Bloody Nora. There's a value, 561.2, 561.6. So I've lost a couple of decimal points because of this rounding here. So it's up to me if I want to give myself some marks or not. Should I give myself the marks? Maybe. So the answer is 222 to 3 significant figures. For my answer here, I do get 222 for 3 significant figures. So I would give myself some marks there. I would, yeah. I want to give myself some marks. So I definitely got the answer there. You get 1 mark or 1 method mark for doing basically kite minus sector. So you get a method mark here. So the 2 marks I'm missing are essentially for the working out of this triangle here. Now I presume because I've got the answer, they would give me this mark here. So I want to look for 31.17 somewhere. So there we are, 31.1. So I get 1 mark for this. And then the next mark is 31.2. Oh, there it is, 31.17. And then actually working out the area of the kite. So the area of the kite was times 2. So here, so I worked out the area of the kite here by timesing by 2. So yeah, I would get full 6 marks. But yeah, this is actually quite a typical question of radians. They'll give you something super easy, which is just find an angle, find an arc length, find an area, and then they'll throw something in that's rock hard, a 6 marker or something. You've got to be aware they're going to mix a couple of things in. They like mixing in triangles, so they're going to give you a right angle triangle. And it's all about how you deal with that. Now, you've done loads of things at GCSE to do with right angles. It's up to you which method you pick. If we go back to the mark scheme, actually finding the triangle, I'll start here. All of this, all of this is for working out the triangle and the kite, essentially. So there's loads of different ways to do it, which makes it a pain to mark. So there are loads of ways of doing it. Find a way you like. I did it by the sine route. You can do it by Pythagoras if you know how to do it by Pythagoras, or you can try doing it by SOHCAHTOA. I believe the first method they use right here, tan pi over 3 is equal to the length over 18. That is SOHCAHTOA. So it's saying tan of this angle is opposite over adjacent. So yeah, it's completely up to you how you want to deal with it. Yeah, that's question 5. I might take a break because I've been doing this for ages. But I'll get on to question 6 at some point. But yeah,